Really excited to be here. Appreciate the invitation. So this presentation, we're going to talk about some cyber activities that have happened historically in space, and we'll get into some best practices as the space industry develops and experts like ourselves, professionals, get involved with helping secure space systems, help bring some good best practices to light to make sure it's on your radar. So to lay a good foundation, we start talking about space systems. If you're not familiar with space systems, here on the Earth, we have what we call ground stations. Similar, think of a ground station as like your network operations center, your security operations center for your enterprise business, your telecommunications company. The space systems are going to have a ground station system where they can monitor and keep up with the health and status of the satellite, the spacecraft itself, and the payloads that are on the spacecraft. And in this example, we have a picture of NASA, who has ground stations around the world for this particular project so that they can control the spacecraft and the payloads. Uh, so no matter where the spacecraft is in orbit, they have visibility and can communicate with those spacecraft. What I found really interesting when I started doing research on this subject is everyone's talking about the cloud. Who doesn't have a big cloud project going on these days? Well, interestingly enough, with all of the new capabilities that are being developed with space, space is also utilizing the cloud. Microsoft, Leaf Space out of Italy, Amazon, AWS, Google, they're all building out a space support capability where you can outsource your ground station to their data center, and instead of having to build your own private ground station network, you can use their infrastructure, which I found real interesting how space is moving to the cloud. But also along those same lines, if you haven't been following in the news, there is a great deal of data center cloud infrastructure that's actually being looked at moving to space. There's a company called Leo Cloud where they're going to put storage capabilities in space. There's Ramos out of Italy that's just developed a 2 terabyte hard drive to put on satellites in space for storage. And I read like a week or two ago that there's actually a company that's going and looking at putting data centers on the moon, actually in lava tunnels on the moon. So space is moving to the cloud. So everybody's doing it. So when we start about satellites and spacecraft, we have different orbits depending on the application of the system. That is the mission. So like Starlink is in the news all the time these days with Elon's SpaceX project with the internet services they're going to provide, and that is going in the very low Earth orbit. About 250 kilometers to 450 kilometers is what's called very low Earth orbit. And then there's a low Earth orbit, and with that low Earth orbit, the satellite is orbiting around the Earth. It's about every 4 hours, it'll revolve around the orbit around the Earth, spinning really fast. And then think about GEO. GEO is like your cable TV services, your telecommunication services, where the satellite is locked in and orbits with the Earth and keeps a fix on a certain geographic area all the time. That's what's happening with GEO. LEO is orbiting really fast, and then the GEO is fixed on certain points. So from a threat standpoint, we start talking about spacecraft systems in space. What the scientists have come up with is they categorize deception, maybe say spoofing, disruption, where somebody maybe an electronic warfare attack, and it's really we're seeing it used to be there was electronic warfare and cyber, but it's really converging together in a lot of the conversations now where with electronic warfare and cyber being under the same umbrella, where say you're doing RF jamming, maybe where somebody cranks up a high capability electronic warfare type system to jam a radio frequency signal, and then it's removed as soon as the power is gone. The jamming is removed, so it's a temporary disruption, all the way to maybe microwave or lasers, where certain capabilities in the spacecraft could be permanently damaged. You could and then the degradation, and then there's been a lot of conversations with destruction. There's 4 countries in the world right now: the U.S., Russia, India, and China, who have demonstrated the ability to totally destroy a spacecraft with a missile. The bad thing about doing that destruction is it creates a debris field, because when you blow something up in space, there's not somebody up there sweeping up the mess. So now when that happens, there are all this debris in space, and so there's a concern now that with space being populated with so many satellites and rockets that have not deorbited, that are still floating around in space, orbiting the Earth, uh, and with ASAT activity where spacecraft is being blown up, it's creating a large debris field. And there's a concern about a chain reaction where a piece of debris hits a piece of debris, or a live satellite that's actually in production, and generates more debris, and it causes a chain reaction where debris hits debris, and it just ends up being a really big chain reaction of more and more debris being created. It's called a Kessler syndrome, where the low Earth orbit will no longer be usable. Hopefully, we never see that. There's a lot of activities going on to be able to start cleaning up uh, the orbit and getting debris out. There's a lot of interesting work happening there. When we start talking about space system threats, in this presentation, we'll talk about some jamming, malware. I got some examples of malware in space, spoofing. Like I said, there's the control network for the payload, for the mission of the spacecraft, and then the spacecraft itself, the TT&C. Uh, and we're going to talk about a lot of the communication, especially with systems that are already in orbit, are not encrypted. I always assumed everything was encrypted. Well, some of it is, and there's a great deal that's not, and we're going to get into some real world examples where things are not. And as we all know from doing our enterprise and other network cybersecurity operations, that if it's unencrypted, then we're opening ourselves up to replay, hijacking, etc., eavesdropping. So we'll get into some real world examples of that. Now, again, when we start talking about attacking spacecraft, we can temporarily degrade the services of spacecraft with like electronic warfare, maybe laser dazzling a sensor on a satellite, and when you pull those sources away, shut them down, then the spacecraft will go on and communicate like it normally would. And so that's reversible. But if we start going and doing what kinetic attacks, where we're actually shooting missiles at the satellite, or we're using some kind of directed energy, some kind of like a microwave, high-powered microwave or high-powered laser, we could have effects that totally degrade the spacecraft that are non-reversible. Uh, when we talk about the actors in space, everybody's pretty much aware of the Viasat uh, episode in Ukraine, where the network management network for the user component of the space system, the user terminals, were basically bricked because someone broke into that part of the network through my understanding, a misconfigured firewall VPN, and were able to change the firmware and push out new firmware that bricked the boxes, is my understanding. Uh, which is really interesting as a network person. That was the vector that they went through the network management there. Uh, but then, so that was a real sophisticated attack from that standpoint. But there's also some really from a nation state side. But there's also some problems from down into the hobbyist. You don't have to be a nation state to be able to go in and pull information from satellites. It's actually been proven. It's been published at Black Hat years and years ago, and more recently in the DEF CON 2 also, I believe, and also recently here in the last couple of years, it's real easy just to go in and pull information off of satellites that passively without actually have to actively do anything, and you can do it as a hobbyist. I know people right now who are using their like a home satellite dish and are passively just pulling internet traffic off of satellite links, and it's unencrypted. Some of it is encrypted because they're using encrypted applications, but the satellite link itself is not encrypted. So the data is only encrypted because the apps they're using are encrypted. Key point there is we'll make through as we go through this presentation. If it needs to be secure, you better be applying your own encryption. Don't assume that somebody else is encrypting for you. So I spent since '99. I've been involved with red teaming and penetration testing for numerous organizations, enterprises, telecommunication service providers, and others, and also teaching it. And I always like to go and look at operations from using a attack tree to tell the story, the step-by-step story. And so in this kind of looking at the space, the way I started looking at it as I was doing this research is the ground station to satellite. You have that trust relationship between the ground station and the satellite. Typically, it was a private ground station. Now, like I mentioned earlier in the presentation, it's moving to the cloud. So, which is going to open up a whole nother level of trust relationships with the cloud infrastructure that is going to be trusted. It's going to need to be locked down. So that's going to open up a really broad attack surface of the insider threat inside of the organization who is paying for the mission, funding the mission, and the wherever we're hosting it, whether it's in our private ground station or in a cloud. We're going to have all that attack surface of that's going to need to be locked down. Now, there's a theoretical scenario that's really interesting to me. I think we're going to probably see something in the future, is satellite to satellite. Right now, everything that I've been reading is ground to satellite, but I've read a couple papers that are talking about satellite to satellite being something to be considered in the future. That'll be really interesting. But there's nothing out there now, real world, that I'm aware of. And then there's a possible scenario, and this is going to be more sophisticated, probably a nation state. Someone's going to have to be really well funded to go and build up a ground station capability to intercept your spacecraft on their own. It's most likely what someone's going to do is attack an existing ground station, a private ground station or a cloud ground station, then pivot off that ground station to go up to the spacecraft. This is going to be probably the predominant vector. Now, this is what I found just extremely interesting. Back in the years ago, everybody was talking about Stuxnet until we were sick of hearing about Stuxnet. Well, I'm going to bring up about Stuxnet again because I found a lot of things, and it was published at Black Hat and a lot of articles on it about apparently when Stuxnet got released and got out into the wild. Apparently, it found its way into a cable TV network in India, and they were actually using the same Siemens PLC controller in the WinCC program that Stuxnet targeted, and it actually targeted the satellite, and it was used to rotate the solar panels on the satellite. Apparently, it fried it, and it disabled that satellite. So I found that very interesting. Now, I'm going back to school to study space systems. I got really interested in space, so I decided I'm going to go back and study it. And what I found really interesting is there's all this space weather. Who knew that there's space weather? I was watching the weather on TV. Well, apparently there's a lot of weather out in space, and a lot of it's generated by the sun. So we have wind, we have all these solar flares, solar storms that are in space, and it's generating all kinds of protons and ions and electrons and putting all kinds of particles out in space. And you measure Einstein's equation E=mc² was used to measure the energy of those small particles, that energy like of the cosmic rays that are being shot through the solar system. And what I discovered during the research and going to school is that all these particles and things over time will deteriorate the materials that the spacecraft is made of, and not only will they deteriorate the materials that the spacecraft is made of, actually doing like a chemical catalyst and deteriorate over time depending on what materials were used, the chemical makeup of the materials. It could also affect the electronics and cause disruption. So I'm referring that to Einstein denial of service. You heard it here first. uh, but, uh, but from a cyber standpoint, the reason you care from a cyber standpoint is, and this is the reason that so much of the satellite communications I discovered is not really encrypted, because those particles that are those ions and protons, all that stuff that's being spewed out into space from the sun, can cause what is called a single event upset, where it will flip bits in the electronics. And all you professionals that deal with encryption, you know that the last thing we need is to have a multi-million-dollar spacecraft in space, and we've got encryption, and all of a sudden we start getting bits flipped on our VPN encryption capability, and so we're going to lose sync, and then we're going to be trying to sync back up, and if we're in a solar storm and have there's a lot of activities. The sun's like here recently been very active with solar flares. We could lose communications with our device because we're constantly trying to resync our encryption keys. So that is the reason that a lot of the spacecraft, especially the low-cost spacecraft, are not using encryption because to use encryption they would have to use radiation hardening equipment, have to improve the materials that are protecting the chips so that they would not lose the connectivity. So to drive down the cost, they assume the risk of not using encryption. And so, as you well know, if we don't have encryption, it's like plugging into the hotel Wi-Fi. If it ain't encrypted, you're on the Wi-Fi. All we have to do is lock into your channel and pull up some Wireshark and start capturing your traffic. It's more involved with a satellite, but the equipment is low cost. Get you a software-defined radio, get the equipment. It's nominal cost, and you can lock in and get your dish, and you can lock in and pull satellite communications off the air, unencrypted, and it's all documented out on the internet. So it just takes a little bit of work, small budget to make that happen. So you can passively sit there and unencrypted capture network traffic. I know a software engineer where I live that no background. He's not a telecommunications person. He's not a cybersecurity person. Just a good software person. Went and made this happen with using a home satellite dish. Very, very little effort. And it's totally ripping packets apart coming off of satellite comms, because it's out there just being multicast out on there. So here's a real world example of unencrypted communications. There was a Navy satellite that the Navy was using for communications. And apparently some real innovative individuals in the radio community discovered that the satellite was using open communications, and so they turned it into a CB radio network for themselves. And apparently it was disrupting, stealing resources from the Navy's mission. So by the time they started doing investigations and all, and arresting people, they ended up arresting 39 people across 6 states in Brazil. And my understanding is, about the time they started getting everybody arrested, other people started using it because it's unencrypted. So there's one example. Here's another real example of proves that things are not encrypted. Like I say, if you need it secure, you better go and put your own overlay network. It's kind of like some research I did on MPLS VPNs a few years ago, where everyone assumes that VPN means virtual private network and implies encryption. VPN does not imply encryption, and just because you're using a satellite comm doesn't imply that somebody is encrypting that satellite for you, because it's just not. And so in this example, there was some malware that was focused on southern Europe, the Middle East, North Africa region, and what the malware would do is a user would get infected, and the C2 server was located on the satellite network. It was set up on to receive satellite communications, and it would just go and use somebody's IP address in that satellite network. And so an end user would get infected, and when they got infected and it phoned home, it would go and send its phone home message to the C2 server on the satellite network. And then the C2 server would send a response back to that infected device over a fixed wire line. So one part of the communication would come in over the satellite broadcast, and then another connection would go, response would go over the wire line. So it was an async. So if you're a threat hunter, and there's a lot of blue team folks here, a lot of threat hunters, It'd be really hard to go and chase that one down where the connection is coming off of one part of the connection is coming off of a satellite broadcast, going to some user's IP address out in that geographic region, and then the return portion of the communication is going over a wireline. That would two totally different service providers. Really hard to tie that one down. But that would not be happening if the communication was encrypted. So for another example was that was proven out was in the news back in 2009 was with satellite video communication in the Gulf War in Iraq was captured unencrypted. Now, I mentioned this earlier. Uh, at some point, with all the satellites being put up in space and everybody's doing internet, all the internet in space and things right now, majority of the satellites are using proprietary or specialized protocols, legacy satellite protocols that have been in place for many years. They're trusted, but things are quickly moving the IP. IPv4 and IPv6 are being used in space, and things move more and more to IP, and all this new infrastructure is moving to space with all the CubeSats and nanosats and all the other satellite services that are being deployed in space. At some point, someone is going to figure out how to do a satellite-to-satellite hack. Like right now, it's totally theoretical. But what I found really interesting is most of the communications right now are RF, radio frequency communications from the spacecraft to the ground, and satellite to satellite is over radio frequency, but it's moving to optical, which is going to be a whole lot harder to intercept when things start going to free space optics for communication. So it's going to be interesting to see how this all evolves. But I want to put it on your radar. So for some examples of real world hacks that have happened, I was really surprised as I started doing this research. I had no idea so much had actually really happened real world. In 1998, there's the U.S. German satellite, ROSAT, that was the ground station. It got hacked. And from that ground station, the satellite was hacked through that trust relationship. Since it's kind of like a network management system, somebody's going to break into your router. The easiest way to hack the router is to hack the network management system first. Well, the ground station in this case that controls the satellite got attacked, and they were able to take control of the satellite and then turn the satellite so that it pointed toward the sun and burned up the capability for that satellite. Then in 2007 and 2008, there was the Landsat satellite that someone hacked. Most likely they got through a trusted ground station, and they had control of it for 12 minutes in this case. And what was published is the attackers had total control of the satellite, but they apparently didn't know how to manage the satellite. And one of the things I've discovered doing some other research is there is a really long list of space protocols, satellite command languages, and satellite operating systems. There's a really long list of each one of those, of the protocols, the operating systems, and the interface languages. So my thought is whoever the adversary was that got onto those satellites, maybe they got the access to the ground station, but once they got on the spacecraft, they didn't know the language syntax. Kind of like me, being a Windows Unix person, getting on an old VAX VMS or a mainframe system. I may have gotten access, but I have no idea what I'm doing with an AS400 or mainframe or VMS box. That's because I don't know the language, the CLI, the command language. So that's my thoughts on what probably happened here with this Landsat 7. Similar was the Terra satellite. The adversary had complete control of the satellite. They had the access. They had the access to do whatever they wanted on two different occasions in 2008. But they apparently, again, similarly to the Landsat satellite, though they had the access, they were not able to execute commands to do anything like deorbit it or something, or turn it toward the sun in this case. So security by obscurity worked in those cases. And here's in this case, there was a NOAA weather satellite. In this case, it was attributed to the Chinese that they were actually able to take full control of the satellite, but then the access was taken back, control of the satellite was taken back, and they were removed from the satellite. But in this case, they had control of it, from what I understand. Now, this one was really interesting. Everybody's talking about ransomware. Well, there was apparently back in '99 a satellite there for Skynet in the UK. The military, they have four satellites that are comprised. They build the Skynet constellation, and one of the four apparently was hacked and held for ransom. So I found that really interesting with everyone talking about ransomware these days in the news. Back in '99, a satellite was held for ransom. So, and with all of the satellites that are being launched into space, a lot of the new satellites are Linux-based, running Raspberry Pis, BeagleBones. Like a little piece of trivia for you, you realize that when Starlink, SpaceX and Starlink, when they launch a rocket with 28 satellites, I was reading that a rocket with 28 Starlink satellites has 4,000 Linux computers on it. That's a lot of Linux. Now, they do a really good job of securing and hardening their systems. But if someone was to ever figure out how to go and do some kind of piece of ransomware, malware, and get it into that Linux kernel, that would make a pretty interesting ransomware attack. So you get ransomware in space. Can't help but wonder, at some point, with everything moving to open source in space, IP, version 4, IPv6, Linux. At some point, are we going to see maybe a ransomware attack in space with some of these new satellite constellations that are going up? Another example of malware in space is there are two events that I'm aware of where Russian cosmonauts working on the space station accidentally, unintentionally infected systems on the space station, once by a USB thumb drive and through a Windows laptop that had malware and brought it on the space station. Now, the network that was infected on the space station was not the flight control system. It did not threaten the flight system for the space station. Apparently wasn't on a sensitive network. They say, control the environmental systems, etc. But it was there was an infection in the network. So now, there's a great deal of work being done in the field of cybersecurity for space. There's an international organization, the Consultative Committee for Space Data Systems. It's an international organization. Lots of countries contribute to it. The standards and best practices for security and protocols encryption are published, just like it is for our enterprise and service provider telecommunications networks. But like everything else, it's out there. We got to go and use it and implement it and do the systems engineering. But a lot of times the systems engineering trade studies have been done, and the risk has been assumed because in radiation hardening to protect the encryption costs money. So it just isn't implemented. But the standards, the best practices are published, but somebody's got to use it, build it into the budget. Don't try to read this slide, but I just wanted, but I wanted to make sure it's available in case anyone wants the slide. These are the current best practices that I'm aware of. They're out there. NIST in the last year has pushed out a couple new standards for commercial satellites and for ground stations. There's NIST 8270 and 8401 from NIST. If you're interested in this, I would check out. There's Aerospace Corporation, MITRE, MIT, Lincoln Labs, NOAA, and also recently CISA and NSA have put out best practices for securing satellite communications. So the standards are being put out there. and there's the Orbital Alliance that's put out some best practices for commercial space. So there's good information being put out there about how to harden these networks, both for users, for the user terminal, all the way to the ground station and the satellite as they're being developed. So if you work for a university, the best practices and information to get these systems hardened to protect them so you can maintain control are out there. And if you want the slides with all these links and everything, I'll be happy to provide it to you. Just hit me up and I'll give it to you. My recommendations is everybody's talking about DevSecOps. We need to get DevSecOps in the space business as we do build what they call Space 2.0. All these new systems, it needs to be hardened. It's great that we're using all the open source tools and we're getting away from old proprietary obscure protocols and operating systems. But as we move, we need to go and start building them DevSecOps from the very beginning and monitor that supply chain and lock down those trust relationships, especially as things are moving to the cloud. It's going to be really important to lock those trust relationships down and protect against what I call the VPT, the vendor persistent threat. Don't let these vendors go and put in back doors for their remote access that are have weak authentication. It turns around enabling someone to help us start managing our spacecraft. One things I'm really excited about, and interesting to see, is the implementation of intrusion prevention systems and logging capabilities actually being put on satellites. There's a big push now with satellites to be developed with software defined. It's called a software defined satellite, where the satellite capabilities are being virtualized. So the payload and all those systems can be virtualized, running VMs as well as containers. And so if you can start running VMs and you can run containers, why can't we have a VM and container with security capabilities, maybe applying machine learning and AI capabilities to monitor the commands that are being sent? We already know what the time sequence and the sequence of commands that we traditionally will be sending to our spacecraft. So if we know how we're going to operate, and that's the time sequence and the delay we expect, the order of certain commands and operations, we can go and baseline that. This should be pretty easy with low overhead to apply machine learning AI techniques to quickly identify some kind of anomaly happening in the network. And hey, somebody's trying to help us run the network, the spacecraft now. And since we're running containers and VMs and things, maybe we can, if we start needing to do incident response, we can revert back to a known good configuration, a known good container, a known good VM, until we can do root cause analysis of what's happening to the system. Now, as I started doing research on this, one of the things I was really happy to discover is there is a lot of open source capabilities out there. So if you want to learn space, you want to learn satellite systems, maybe for yourself, for your company, or you want to take it back to your university, and hopefully maybe go back and help your high school students and other students that have the aptitude and interest in science. There's a lot of tools out there that are free, and this stuff will run in a container, run in a VM, run on a Raspberry Pi, BeagleBone. This NASA Core Flight system, that is satellite software, and it'll run on a Raspberry Pi or your BeagleBone, or run in a container. You can download it for free. The Ball Aerospace Cosmos is actually ground station software. It'll manage IoT devices as well, but you can manage CFS with the Ball Aerospace Cosmos. Real nice GUI, point and click. It's a nice tool that you might want to play with. And NASA 42 is a space simulator, and it'll do the whole orbit simulation for you, all in a nice environment. So it's all free. And similarly, NASA offers the NASA Operational Simulator for Small Satellites, NOS3. That's also available out on GitHub for free. That's another satellite you can play with. And then if you want to go and look at doing satellite tracking, there's the Artemis Project and SatNogs. They're pretty interesting. But the OpenSat kit's pretty popular, and I'd highly recommend, if you're interested in learning more about satellites and playing with and getting familiar with protocols, etc., go look at the OpenSat kit that NASA has released. It's got to work. NASA put it out there. They know a little bit about space. But that's what I had to present to you guys today. really appreciate the Security Fest team giving me the opportunity to come to Sweden and hang out with everyone. It's been really nice. It's a beautiful country. It's really nice. It's, before I step off stage, are there any questions?
Come on, guys. Don't be shy. It's about space.
Yeah.
Can you repeat the question, please?
Oh, with, are you talking about satellite to satellite? Yeah. Well, the satellite he's asking is the threat changing? Like with Starlink, with all the large constellations that are going up with satellites. There's a lot of large constellations going up, not just Starlink. I'm, space is really huge. So if satellite got attacked, if someone was to take control of a satellite that had propulsion capability, theoretically, you could drive that satellite that's been taken control of and try to go and drive it into debris or to another satellite. But the vacuum of space is really huge, so it's going to have the fuel and be in the right orbit, right place where it can get to that point. Uh, well, that's all. Yeah. So from the cyber side, it's all theoretical right now. There's nothing that's been shown to happen that I've been able to read. I just read a couple papers where a few people brought up the idea, but I'm sure something could happen in the future. Maybe especially if they're trusted. Maybe if there's a satellite, there's a couple satellites that are talking to each other. They're part of the same constellation. They have that trust relationship where they're talking over. Uh, Optical free space laser communication, which is being talked about a lot right now, or RF comms. Maybe through that trust relationship, a satellite could be used to exploit another satellite. But that's right now it's all theoretical. But it's certainly something that could possibly happen if someone has the knowledge of that constellation and how it's orchestrated. It's like I said, it's theoretical, but it's probably possible. How much of what we deal with every day was theoretical, months ago. Now it's happening.
All right. Anyone else? Don't be shy. He's putting the cyber back in cyberspace. Come on, guys. All right. Looks like that's it for questions. Please join me in thanking Paul again.
Thank you.